All right. So today, today we're going to be talking about not the Titanic. We're going to be talking about the addition method of solving equations.
No, I hate addition.
So the did you know question for today is, did you know that you can add or subtract two equations from one another? So if I have an equation like 2x plus 3y equals 17, and I have another equation like x minus y equals 10, I can add those together. And when I add them together, I can actually generate a third equation, but that third equation is dependent on the other two equations. And when you add, you want to make sure everything lines up. So notice my x's are lined up, my y's are lined up, my equal signs are lined up, and then my constant terms, in other words, my regular numbers are lined up. So this is a 1x. So adding those, I get 3x. How many y's would I have? 2. Yeah. Plus 2y equals 27. And so what I have done is taken two what are called independent equations. They're independent because they're two different equations. Added them together and generated a third equation. Now that third equation is dependent on the other two equations because you generated it by adding the other two equations together. I also could have subtracted the two equations. So if I take the two equations, let me just rewrite them. Always fun. And I subtract them, I can get x plus 4y equals 7. All right. Now, you might ask yourself, quiet please, why would you want to do this? What does this accomplish? Well, in this case, it accomplished generating two other equations that were dependent on the first other equations. But in some cases, we accomplish other goals. So let me show you when we can accomplish other goals. So what we can do is actually solve a system of equations using what's called the addition method. I generally don't call it the addition method. I call it the elimination method. Because when you add the two equations together, if you do it strategically, let's stop throwing things. You are able to eliminate one of your variables. A very fancy way to refer to this is called linear combination. That's what they call it when they want to intimidate people. And so the first step when you're going to add equations together to solve systems is you get both equations in standard form. So standard form means you have the x's first. So for example, it would be like 3x plus 4y equals 10. That's standard form. Y equals mx plus b is not standard form. Standard form is x is first, then y is the equal sign, and then the numbers. You want to identify or create what are called opposite coefficients. You want one of your variables to eliminate or to cancel out when you add them together. And so that's why you want to either identify if they're already there or create opposite coefficients so that when you add the equations together, one of the sets of variables eliminate and cancel out, and then you can solve your system. And again, I believe your textbook calls it the addition method because you're adding the equations together. I call it the elimination method because the goal is to eliminate a variable. Because if you have something like this, x plus y equals 10, x minus y equals, let's say, 12, and we add these together, do you guys see what will happen? 2x will equal 22. And then we can solve. So if you set it up, or if you're given equations where this is true, one of your variables will eliminate. And it makes solving very straightforward. And then you can just plug this into one of the equations and solve. All right, so let's do a couple. So the first question you have to ask yourself is, if I add these equations together, will one variable eliminate?
Yes.
Yes. So that means I can add these equations together. I mean, you can always add them together, but it will actually accomplish something. So how many x's will I have?
No. I said my answer, I'm sorry. Is that not right? All right.
That's all right. So 10x would equal how much? 30. Okay, 10x equals 30. And then I'm going to divide both sides by 10. And then x equals 3.
That's what I meant.
Yeah.
So y'all choose me a wrong.
Okay. So because this one had opposite variables, coefficients, the y's, one of the coefficients was -2, and the other coefficient was 2, I could add them together and they would eliminate. So x equals 3. Now, how do I find y?
Well, you're into
Not me?
3. 5 and 4. So check it. So you do like 6 times 3 minus 2y equals 10. And 4 times 3 is 2y. Or no, wait, no, I'm sorry. It's 4 times. What? I can't do this.
You're doing great. So not me.
Just insert 3 more x's.
Okay, great. Do you care which equation you do that with?
No.
No. So let's do it. I'm going to do it down here because the y is positive.
Oh, you don't do this above equation 4.
Well, you only need to find y once.
Nutcracker. I just like wrote it all out thinking I got it right. Wait, so why? How come you do it whole time?
Why do I have a parenthesis there? Well, you only need to find y once. So,
Oh, so okay. I got it.
okay. So I substituted in 3 for x. Okay, let's move on. So we're going to subtract 12 on both sides.
I looked at it again.
Why do we get simple answers for these complicated things? I don't get this. It's literally 3 and 4. And then we gotta go, okay, why do we have to go through all these numbers just to find out that, no, x is at 3 and 4? Like,
Okay, well, in calculus 3, oftentimes we'll have a problem that takes an entire page,
alright.
and then the answer is 0. So,
I said the answer was 0.
did anyone check to see if this works?
No.
Did it work? No, but did you check it in any of the equations? No. Okay, front row. Front row, check it in the top equation. Back row, check it in the bottom equation.
Check top row. Top row is good.
Oh.
Okay, what was some of the?
Oh yeah, that's what that. Sorry.
Alright, bottom, it's good.
Yep. Yeah.
All right, let's move along.
That's good.
All right, take a look, please. Now, if I add these together, will any of the variables eliminate?
No.
No. So this is where you need to know another interesting fact. The other interesting fact is that you can multiply either of the equations or both by any number. So what I'm going to do is take the top equation, and what do you think it would be easier to eliminate, the x's or the y's? Now, the x's. So if I'm going to eliminate the x's, what do you think I should multiply the top equation by?
2.
2. Good. Because if I multiply the top equation by 2, do you guys see how now I'm going to have opposite coefficients for x's?
Yeah.
Now, I have to multiply the entire equation. Left side, right side, all the coefficients.
Why is that even longer?
Sorry, my iPad's trying to far.
So
It is 6.
Okay.
The answer's 2.
we're times 2 by 2, so it's 2.
Why you know you just
So
Hey, I can't you do it back. Why not?
we should have together and cancel out.
No, I say that.
And seeing the second one helps with.
Okay, so now, so we're going to add these together. The 2x's eliminate now. And so I get 5y equals -10. Then I can divide both sides by 5. It's 0 because -2x plus 2x is 0. So y is -2. Now, if you were thinking about substituting this in, which equation would you substitute it into, Brendan?
Second one. Wait, yeah, right? No, wait, no, first one.
Yeah, there are many choices. If you guys could all look forward, you have the choice. Well, first of all, any questions on how we found y? Okay, now looking at all these choices, we have the original 2 equations. Then we have the equation we got when we multiplied it by 2. We have a bunch of choices. You can multiply or plug y equals -2 into any one. I think I'm going to do it into this one, but it doesn't really matter. Okay, so first thing I'm going to do is multiply 3 times -2 to get 6. You can plug it into either. So your order pair is 6, -2. Uh-oh.
What'd you say?
DJ?
I'm kind of confused why you multiply it by 2. Yeah, me too. What makes that happen?
Okay.
It makes
So,
an opposite.
All right, so let's quiet down, please. Focus. If you just added these together, the x's would not cancel. Yeah, because the goal is to get one variable into the equation. It's called the elimination method. And so if we were to just add these together, the x's would not cancel. So you have to get one of the variables to cancel. And so by multiplying the top equation by 2, when I add these together, I have negative 2x plus positive 2x. Those are opposites, therefore they cancel. Let's look at this one. Do any of these, so if I just look at this, DJ, if I add these together, will anything cancel? So Lisa, will anything cancel? No, so you have to ask yourself, what do I want to cancel? The x's or the y's? Yeah, x's are probably easiest to cancel because this has a 3x. I can make this something that will cancel with 3x. What will cancel with 3x? Yes? Negative 3x. So DJ, what would I multiply this bottom equation by? Negative 3. All right, so this is negative 3x, negative 6y equals negative 18. What's that? So that is called the substitution method. And we're learning a method called elimination. Not at this point, because at this point we're learning the method that's called elimination. So our 3x's cancel, Isaac?
Can you divide? It looks like it's easier to divide with something.
You could have, yeah. Not me?
Okay, so every time there's an x, like x plus 2y equals 6, you multiply by the opposite number that's on the top with x.
Because you need them to cancel.
Okay.
So you need the coefficients to be opposites. Okay, so y equals 1. So then I'm probably going to plug that into this equation, y equals 1. So I get x plus 2 times 1. It is not time to pack up till I tell you, so chill out. I can still see you. You are not invisible. So x equals 2 plus 6, so what is x?
Oh, 8. 4, I'm sorry.
4.
Negative 2.
Sorry, x plus 2 equals 6. So x is 4, so 4 comma 1.
Thank you. Wait, wouldn't you have 3x plus 2 and then the one equals 6? X for the x plus 2, when the x. Oh wait, no. Never mind. I thought we were using the other equation. That's why.